we have given some kind of the problems we may have given here, and I am basically showing you the code, how to write the program for the particular problem, and just showing you to the output of the program using the Google Colab. So already we have seen in the last two session, in the yesterday session, we have seen that what is the Google Colab, how the program is being compiled, and how we can see the result. So if anyone having any issue or any kind of you wish to discuss any kind of the uh, issues may have found during the execution of the program, may please raise your question here, or I may start the session accordingly. So okay, let me start the session. No issue has been raised. So let me start the session. So today we are going to discuss about this is the third session. So we are going to discuss about the alpha beta pruning algorithm. So alpha beta pruning algorithm. In the case of the min-max algorithm yesterday, in the case of the min-max algorithm yesterday, min-max algorithm yesterday, that this is a game playing algorithm. The first thing is that this is the game playing algorithm, and always in the game there are and this game playing algorithm is between of the two players only. So this is the two players game playing algorithm, either the min-max algorithm or the alpha beta algorithm. This is the uh, two-player game playing algorithm. So in the case of the two-player game playing algorithm, if you are person X, if you are person X, so you are suppose that you are starting the game and you are the person X, and this is your turn. So you are turned you after mm, moving your turns, after moving your turns, you may either go in you may take only two decisions. Either you may go to this particular situation, or you may go to the this particular situation. So so one particular decision you will take. So if you are taking two decision to go this way, so now this is a turn for the Y. So in the first, it was turn for you. It was turn for you, and you have placed your dice, and now this is a turn for Y. So accordingly, the Y again have to take some certain decision, and the Y have to take some certain decision. So suppose that this particular decision was taken by the Y, and thereafter this was the Y turn. Now it will become your turn, and according the leaf node basically tell us that what is the winning chances you may have, what is the winning chances. So this leaf node having the some utility values, like some positive number, some negative number, so that uh, you may lose the game. Positive number, so that if you follow this path, you may win the game. But the thing is that you cannot directly select the best part, because you have to go through the Y turn as well. So depend upon your turn and the your opponent turn, we may predict that who is going to win the game, or what strategy need to follow to win the game. So this what we have seen in the case of the alpha min-max algorithm yesterday. Now the question is that the search tree, this the tree which is coming, the tree which is forming here, this is known as the search tree or the search space graph. Also, it have a various terminology. It is known as the search tree. It is known as the space graph. It is known as a so state space search or the state space graph. So you can see again this state space search or the graph. It is so the number of the node in the state space search and the graph is for the even for the tic tac toe, it is going abnormally very large. If we talk about some larger game where a lot of steps need to be required, like your chess game. So the the chess having the number of the rows, the chess board having the size of 8 by 8, and it was calculated for this one, the size of the board of the 8 by 8, and in order to predict, in order to create this state space search, it required 8 into 8 to the power 50 of the size number of the nodes will be in the state space search for the chess game. Means 64 to the power 50 would be the number of node in a one state space search. So you can see that for the very simple game like tic tac toe, like Nibby game, we may go with the state space search. We may go with the min max algorithm, and we may compute the winning chances or the winning situations, etc. Your winning situations and the chances. But for some bigger game like a chess game, a state space size would be much more larger, and which is not easy, which is not easy by the simple system to calculate this much number of the state space, this period of the this much state space. We required a huge number of the memory power, huge number of the computational power here. So the concept of the alpha beta pruning has erodes here, and the concept of the alpha beta pruning is say that if suppose that we have moved to this particular situation, if we have moved to this particular situation, we may remove this one, we may remove this sub graph of the sub part of the tree. Why we remove? Because once we have moved to this particular direction, once we have moved to this particular direction, your opponent is only it, your opponent is restricted to make a decision in this subtree only. Your opponent is restricted to make a decision in this subtree only, and thus this subtree, the another subtree, we can simply delete, or we can simply prune here. That's why this is known as the alpha beta pruning. Pruning means you are pruning just like you are pruning branches of a tree. So similarly here we are pruning the branches of this tree, this binary tree, so that unnecessary or unutilized subtree can be deleted, and the mode space can be created, and the computational load can be reduced. This is the basic purpose of the alpha beta pruning. Now, which branch need to be pruned, which subtree need to be delete. That is the technique of the alpha beta pruning. So in the min max algorithm in and the alpha beta pruning, there is no much more difference. The difference is that we are working with the min max algorithm. We are going with the technique of the min max algorithm. However, in the case of the min-max algorithm, we are going with the entire tree, entire binary tree. Whereas in the case of the alpha beta pruning, now we prune the unnecessary sub subtrees here. So that is the basic concept of the alpha beta pruning. So let me show you. Let me show you the code for the alpha beta pruning. So the alpha beta pruning code is much similar to the min-max algorithm code, whatever we have seen, and due to the restriction of the space and the code, I am just going to show you the alpha beta pruning algorithm on the same game which we have seen yesterday. That is the min-max algorithm. So let me show you the code for the alpha beta pruning here. So let me show you the code first, and then we will go with the execution of this one. So let me share the code so that I may go with the code, and then I'll be show you how to compile this one. So now you can see on your screen the code for the implementation of the alpha beta pruning. So in the case of the alpha beta pruning, as I told you that this is a much more similar to the min-max algorithm. So most of the code is similar to the min-max algorithm. Just we need to discuss about the pruning part here. So for the simplicity, let me discuss. So this particular function is printing the board. We already have seen yesterday. We have seen about the winner. We have seen about the code for the winner function. So few functions we have created in order to execute the min-max algorithm. So similarly here we have some function here. So you can see here that so this is almost same whatever we have discussed yesterday. So we are printing the board here, and these are the available moves we are taking, and then we are going for the alpha beta pruning. This is the major part of your algorithm. Just a minute. So this is the major function of for the today's discussion. So this is your alpha beta pruning. Everything is would be the same with the min max algorithm we have discussed yesterday. So in the case of the min-max algorithm, we are going for the maximizing situation. We so as a player, I will always try to maximize my winning chances, and my opponent will always try to minimize my winning chances. So in the case of the min-max algorithm, we have seen that how the leaf node having the sum of the utility value, the leaf node having the sum of the utility value in the state space tree, and based on your turn and your opponent turn, we are calculating the winning chances of uh, your winning chances basically. So basically, always I will try to maximize my winning chances, and my opponent will try to minimize my winning chances. So as a winning, so as a, as as I wish to go, as I wish to maximize my winning chances. So I will always try to move towards the highest utility value, whatever the highest positive utility value, feasible utility values. I will always try to move in that direction in the state space tree. Whereas my opponent who is always try to minimize my winning chances so that their winning chances will increase. So my opponent will always try to move in the direction which having the lowest utility value, even in the negative utility value. So accordingly, the opponent will choose their path. So this is the basic of this one. So you can see here that so in the pruning part you can see here that so each winner, so we are taking the each winner function here with the board, with the opponent, and with my parameters here. So each winner is two parameters is being passed: the board parameter and the turn parameter, me turn and my opponent turn. Whereas the alpha beta pruning functions basically take the five parameters: the board, the depth, the alpha value, the beta value, and the maximizing. Is maximizing. So is maximizing is checking that alpha or beta value, which is going to be providing the maximizing value, and accordingly the sub part of the tree can be erased, can be deleted here. That is the that can be proved. So each mask, so you can see here that so one by one, at a first, one of the player is moving their dice, whereas the another in the next chance the another player is moving their dice. Now the maximizing function. This is the one of the most important function for the alpha beta pruning. The maximizing function basically check that where the move is going on in the state space tree, where is the move is going on, and accordingly it may prune. So once both of the player has once the both of the player has moved their once the player has moved their dice, now the maximizing function will check that which sub part of the tree is not going to be visited by the selection of the both of the players move, and accordingly the maximizing function will prune the tree, the state space tree. So it may evaluate and get available moves, and so get available moves. So this get available moves will always, the get available moves will remain the subtree which is going to be visited by the move of the both of the players, and the rest of the trees is going to be pruned. So alpha beta pruning here. So alpha beta pruning. So board depth plus one alpha beta, and then it is false. So thing is that let me see us one again. Let me see the once again uh, the tree. Then you may easily understand here. So you can now, by looking of this tree, you can easily understand about what the code we have discussed right now. So here, so what we have seen, that once the one of the player has moved their dice, thereafter what is happening here? Once one of the player has moved their dice, so X has moved their dice. Now this tree is available tree. This is the tree which is available, and this tree is need to be make as a false. This tree to make as a false. Making of the false means I am not going to visit in this direction, because I have the X has the player X has moved in this direction. So now the another player Y is also bounded to make a selection from this subtree only. Make a selection from this subtree only. So Y is not my opponent, or the another player is not going to visit this subtree. So this subtree need to be pruned. That is the basic concept of this one. So the depth plus one, so depth plus one. So if I have moved into the one particular direction, so another direction is going to be deleted. So depth plus one is going to be deleted. So deleted means the visibility is going to be uh, as a visibility of that particular is going to be hide, so making it as a false. So let me once again share the code. So let me once again share the code. So now you can see, now you can understand, what is the depth plus here and the alpha beta. So accordingly, the alpha beta, and it is going to be a false, making it as a false. So making a false means now that portion of the tree is not going to be evaluated. And thereafter we are updating the alpha beta for the next turn. We are we are getting the alpha beta for the next turn, and the minimum is going to be allowed. So in this way, so the maximizing function will maximize, and it will hide, it will calculate the mean value and the max value, and the rest portion is going to be prone, and another portion is going to be make as a true. So this is the alpha beta pruning. Rest of the code, rest of the function we have discussed yesterday are almost same here. So so the first move, the best move, and the first move we already have seen. So we have to find out the best move in the available moves only. Get available moves only. We already have seen in the upper part. In the available moves only, the available moves are being scored as per the alpha beta pruning. As per the alpha beta pruning, whatever we have pruned. So here it is going to be false. So that sub tree is not going to be evaluated, and this subtree is going to be evaluated only. And based on that, we need to calculate the score. What is my winning chance? That is the score. So finding of the best move, and the score is being calculated. And this particular function basically creates the board. I'm going to show you with the tic-tac-toe. So this is the board. This is the board architecture, and showing the initial board. The, while it is a true, it is split, and accordingly it will proceed. So, so we have seen that your moves, and the computer moves, and so now let's. So this is your code. Now let me show you the how to execute this one. So let me share the Google Colab screen, because the Google Colab is there. Google Colab is there, where which provide us a snapshot to execute the Python code. So let me create and let me share the Colab. So now Google Colab screen is visible to you, and now let me uh, take the code and make it paste here. So so it is highly required that you should have idea about that for what algorithms we are going to execute, the in what particular problem we are going to discuss into the particular session. So it is expected that you first read the theoretical part of that particular topic from the AI, artificial and the machine learning block. So okay, so now the code is now available. Code is now available in the Google Colab, and now let me run the code. So my code is going to compile, and based on the time, based on my internet speed and the code space required, my code is going to compile here. So please wait. It is moving on. It is moving on. It means that my code is compiling, and once the Google server will compile my code, it will show you the FTM. So you can see here that it is showing the initial board. Initial board means, so let me so initial board means, so you can see here that in the code we are first, so we are calling the function main, we are calling the function main here. So you can see here that the function main which generate the initial board, it will generate the initial board, and the initial board is going to be printed here. So initial board has been printed. Now it is asking enter your move, means the row number and the column number. This is a tic-tac-toe game. So so you can hear that a 3 by 3 board has been created here, and now I have to enter my move. So I you will always be a first player here. So now I have to enter my point, my mark into the particular row and column. So let me give my mark to the row number 0, and the column number 0. Means this particular cell I wish to place my mark. So you can see here that, so this particular code has shown the initial board, and this particular code is basically asking me to point the row and column. And if I am providing the invalid move, then it will display this one. Otherwise, it will show you the board after your move, means after winning of X, after executing of my marks and the opponent marks. So computer moves will be there. So I have my moves, and thereafter the computer moves will be there. So let me put the 0 0 here. So now you can see that as soon as I had put in the 0 0, so you can see that the my marks X is pointed into the tic-tac-toe game, and thereafter the computer has executed their code, and the computer got to place their marks on the board. Now this is my turn. So this was my turn here, and thereafter it was the computer turn. So this is the board situation after the computer turns. Now it is my turn. So let me put my my mark here. So I may mark, suppose that I wish to mark here. Or suppose that I wish to mark here. I wish to mark here. So this what is the serial number of this one? Row number 0, row number 1, row number 0, row number 1, and this is the row number 2. This is the column number 0, column number 1, column number 2. So this one would be calculated as a row number 2 and the column number 0. Row number 2 and the column number 0. And thereafter, let me put this one, and let me see here. So you can see here that. You can see that. So so I have moved my dice, and there after it was a computer turns, so computer has moved their turns here. So you can see that. So in this way we are going to execute the game. So Let me put the another mark. So let me put here, otherwise the computers will win. So this is the situation. Row number one, column number two. My marks is there, and the computer has turned here this one, and thereafter, uh, I this is my turn. I must put my mark here, otherwise the computer will win. So, so row number two, column number one, and marking my point here. So I have put it my mark here, and thereafter, so, so this is the situation after the computer moves, and only one cell left, which is this, and thereafter no more turns, and based on that, the computer will decide who won or the match was drawn. So let me put in this one, because until unless you will not put the mark, because it is your turn, you have to put your mark, and thereafter the computer will decide who has won the game. So it is a draw. It is a draw because there is no more move left here, and accordingly a draw situation has been done. Now let me once again compile. Sorry, whatever. So let me once again compile the code, and let me show you with some other situation. Hide this. Okay. Now let me compile once again, and let me show you uh, which recording something. So let me put my marks here. The row number one, column number one. So this is a situation, and now let me put my mark here. You may decide as per your convenience. You can see here that, and obviously, and suppose that I am putting my marks here. Let me computer allow to be. So let me put my marks here. So row number two, column number two, and I have made the mark here. I have made the mark here. Thereafter, the computer has put their marks calculated by the pruning algorithm, and this was the computer. So this is the code we have seen about the alpha beta pruning, and we have seen that how the state space tree is being pruned here. So this is the code we have seen, and this is as per the session requirement, your session requirement. So this is the only problem we need to discuss in this particular session. So alpha beta coding. So now, I have shown you the entire scenario here, and let me put the code here, so that you may have some code. You may have some predefined code, so you may execute this one. So I don't have any issue. Let me put my code here, and if anyone having any issue, so please put your question here. I am putting the code because the chat box having some limitation that it cannot accept more than this much number of the characters. So one by one, I'm going to put my code in the chat box. You may copy it from there, and you may execute. Let me put the code by one definition in the chat box. So I am putting the code the way I have discussed here, and shown you the result, and accordingly you may put equally you may copy and try to execute the same program in the Google program. one, one by one. I'm putting the entire code in the chat box. Please copy from there and try to execute the code by yourself in the Google Colab. So you may have some uh, confidence about this one. Let me put the code. So the entire code is now put it in the chat box. And you may take the entire code from the chat box, and this is your turn now to execute the code in the Google Colabs. Open the Google Colab. We already have discussed that how to open the Google Colabs and how to execute the program in the Google Colab. So this is end from my side. Now this is your turn. You may please try to execute the code in the Google Colab. And if you are facing any kind of the issues or you are getting any kind of the error during the execution of the code, please let me know. So I'm here only. I'm here only, but I'm now muting myself, and you may please try to execute the code in the Google Colab. And if you are facing any issue or any difficulties, or you may wish to discuss anything about this code, I'm here. So now it's turn. You may please try to execute it. And if at any time, at any moment, you feel that you need some discussion, you may please unmute yourself and you may put your question there. So please try to. I'm here. this is the only this is the only problem we need to discuss in this third session, that is the implementation of the alpha beta pruning. We have seen about the implementation of alpha beta pruning. So if anyone having any doubt, you may please put your doubt. So we have a further discussion on this one. Or this is the end of the session from my side. I I'm so I have demonstrated you the complete alpha beta pruning algorithm, and I also have demonstrated you how to execute the program, how to how to execute the program, what is the code running behind this one, and what is the we have discussed the various code and the so this is the end from my side. If anyone having any doubt or you need to discuss anything about this problem, you may please unmute yourself and you may. Okay, thank you, Sylvester. So I think that I have completed from my side, and I'm here. If anyone having an issue, you may please put. Otherwise, I have completed from my side. This is the end of session from my side. Thank you, Sylvester. Thank you very much, Sylvester. So if anyone having no doubt, the session may be ended, and we will meet tomorrow for the next session. Yes, tomorrow as per the schedule, whatever the schedule is there, tomorrow from 3 to 4:30 p.m. So we will meet tomorrow at as per the Indian time. We will meet tomorrow at 3. Sure, sure. If any if you have any kind of a doubt from any of the session, not only the today session, if any one of the previous session, if you have any doubt, you may come up with your doubt and we may discuss tomorrow as well. Okay, Yusuf.
No, sir.
Okay, thank you, Sylvester. Thank you very much.
Okay, thank you, sir.
So
See you
now,
tomorrow at the same time.
sure. Okay, thank you everyone. Thank you. Bye bye.